There we go. Lesson number 5. Inverses. Okay. So we're going to do a little introduction. Given y equals 2 to the x. Okay, super simple, exponential. I'm going to sketch just a very small picture, right? Just little. I'm going to show my asymptote. And I'm really... Okay. Okay. Pretty good. I guess I can put, right, one other point. The fraction points are kind of hard to plot, so I'm just going to show the 2 integer coordinates there. And what we're going to do is, remember, inverses are kind of circular. Algebraic and graphically, doesn't matter which way you come up with the inverse. It just matters that it all corresponds. Okay. The inverse is, okay, just going to leave it y equals for a moment. And we're going to see if we can't figure out what the inverse is supposed to be. But I'm going to do it graphically because I'm pretty confident about this graph. And I'm like, I don't really know what the inverse is. All right? So let's take same size graph here. And let's switch the coordinates and plot them. Okay. So I'm just going to list my coordinates here just to help me. So I've got 1, nope, I've got 0, 1, 1, 2, and I'm going to say y equals 0 because asymptotes switch also. All the letters switch. If domain and range switch, so do the points in the asymptotes. Okay. Switch them. Okay. I'm better at actually writing things down to switch them. Right? All of the letters switch. X and Y switch for inverses. And so I'm starting with what I know in exponential graph, and I'm switching the information to create the inverse graph. Well, it's a log graph. The reason inverses and logs are in the same unit is because they're inverses of each other. Right, so we're going to work with that. So this is going to be log base 2 of x. Why do I know it's base 2? I look at my other point. The 1, 0 point, that's connected to the center. The next point is what helps you determine the base. Exponent of 1, base of 2. Look at the units. It's how many units away from that asymptote that help you determine the base. Okay. Now, once you start getting 2 graphs, you're like, oh wait, where does my asymptote go? See how the log has an L? It looks like a vertical line. Helps me remember that the logs have the vertical asymptote. Right? There's only one type of graph on your quiz. It's just horizontal asymptote. But now, you've got 2 types of graphs. You got to get the right asymptote so that you get the right shape. Try to put a vertical asymptote in this graph, it's going to look weird. Try to put a horizontal asymptote over here, it's not going to work. Okay, so logs have the L, helps me remember they have the vertical asymptote. Okay, so small, that's not a proof, that's just an example of how exponentials and logs are inverses. Okay, so we're going to actually find the inverses. We're not proving anything right now. We'll prove when we get back. We're just going to find the inverse. Given the equations, find the inverses. Okay. We're going to start with f of x equals log base 3 of x minus 2 plus 4. Okay. If I start with a log, the inverse should be exponential. Okay. If we remember, the first thing we do, switch x and y. Okay, switch x and y. X equals that's my first step, is to actually switch the letters. No proving, just finding inverses. Switch and solve. Switch and solve. That's how you find them. Okay? Solve for y. So I'm going to highlight y just because that's the part that I'm trying to get by itself. And so notice it's just one variable. I'm going to start undoing the things around it. So I'm going to minus 4. Okay. You're like, how do I get to y? Somehow I have to get rid of this log base 3. Now this is not multiplication. Okay, remember when you did trig in geometry, sine of 30 degrees. You never divided sine. It's sine of 30 degrees. Okay? I can't divide log base 3. But could I rewrite this into the other format? Can you rewrite this statement as an exponential? And see what happens. So I'm going to say switch and solve. Rewrite. Right, that little first part of your quiz, rewrite it. I'm going to highlight the different sections. I like to circle my base. I like to identify the base. The base is 3. Then I've got this thing, and I've got this piece. I have 3 pieces. I need to place all of them correctly. So when I rewrite it, I'm going to start with the base 3. And then I'm going to place everything where it belongs. So I need something here. And I need something here. Notice the level. I need an exponent and I need a regular level, like a base level. Okay. 3 to the x minus 4 equals. Rewriting it is actually undoing the log. Can you get y equals? Yeah, add 2. Now I'm going to add some grouping symbols for my exponent. And notice that I'm trying really hard to get that exponent grouped and then plus 2 so I don't accidentally add the negative 4 and the 2. That's it. Now if I remember my notation, I should really say F inverse. Right, if we're going to start with F, then you should end with F. Okay. let's say f of x equals, we'll start with an exponential. I like to group. Notice there's no a values yet, just h and k. Switch and solve. Solving is going to have that rewriting technique. Okay, switch. Highlight y, right? Y is what I'm aiming for. But keep in mind those grouping symbols, they just don't disappear. -1. Okay. Notice that I've gotten like as far as I can. I can't -3. That's an exponent. The only way to get from here, the exponential, to the next step, that's the rewriting step right here. Rewrite it. And so I'm going to circle my base because I really need to keep in mind what my base is, because the base isn't going to change no matter which format I'm looking at. If I look back at the beginning, base 2 on the left, base 2 on the right. I need to keep track of what my base is because that's where one of the things that I can identify. Okay, so I'm going to circle the base. And now I'm going to try to turn it into a log equation. Log base 2. And I just give myself places to fill in. The base I can pick out. Every time I'm like, okay, where do the other two pieces go? I need x minus 1 and y plus 3. Notice that they switch sides. The 2 was on the same side as the y plus 3. And now it's on the same side as the x minus 1. Switches sides. But also, the exponent came away from the y. Now y is all by itself with the plus 3. Okay? And -3. But if I start with f, I'm going to end with f. Don't lose your grouping symbols. They matter for your transformations. This one is left 3, up 1. This one is right 1, down 3. You want to 3 and 1, 1 and 3. Make sure those transformations actually stay the same. Okay. Give this one a try. Okay. Negative log base 2 Okay, there you go. Now I added an A in terms of transformations. It increases the steps needed. Switch. And solve. Okay. Well, that negative, I'm going to put it on the other side. But I don't want to lose my transformation, so I'm just going to leave it as the negative in front of the parentheses. Notice that when I rewrite this, I have to isolate that log statement, or I have to isolate the exponential portion before I rewrite it. Okay? And rewrite it. I'm going to circle my base. Notice that when I circle my base, it's on the log. That means that I need to turn it into an exponential. Exponential and logs are inverses. So if you start with a log, you should end with an exponential. Okay, so 2. Right? There's my other places. Fill in the missing pieces. Oh, that's it. But I'm going to do one fancy property. I don't really like that negative in the exponent. Notice how it's multiplied. So I'm going to use my exponent property that lets me do 2 to the negative power. I'm going to leave the x plus 2 there. F inverse of x equals 1/2 x plus 2. Right? I was going to be fancy. They're both right. These are both correct. But if this were multiple choice, you would need to identify that this is also correct. Right? Maybe I do a little bit of the properties that we practiced right at the beginning of the unit in order to get something that's a little easier to graph. That's decay. I can pick that out really quick because of the base here. Okay? They're both correct. This is just a little more simplified. If this were free response, full credit, both of them. They're right. Multiple choice, you got to be able to rewrite things until you find the answer that is there. Okay. I'm going to give you questions 4 and 5, and that's where we're going to stop. Okay? And then you'll have the rest of the class to kind of relax and sit, maybe type in SOL answers or find those packets if you haven't yet done them. Okay? Yeah? All right. There you go. Four. Okay. Y equals, E. E is just a number. You can do it. X plus 1 minus 2. And I'll give you Y equals 2 log base 1/3 X minus 4. Notice the grouping symbols on the X. That means that the vertical asymptote is x equals 0, and then it's shifted down 4 units. The grouping symbols help determine your transformations because it's putting, right, what goes with the x and what's outside. H is inside, K is outside. Okay, so the grouping symbols matter. All right, just a little reminder. Switch. Isolate Y. Rewrite. Right? While you're isolating Y, you're going to need to rewrite it. didn't know what ln e was log base e. I would probably write it log base e. I used to write it. Yeah, log base. When the base is a fraction, try to group it so that you know it's log base. Alright, let's toss up some answers. See what we can do. Okay, did what you get match what I get? Okay, so you compare your answer to what I have and see if you can make it match. Now, I'm sure you might be right, just maybe not all the way simplified, or just missing one last step. How about I put up the step right before it? The one that you probably have. Yeah. All I did is square rooted the base, right? Now, it's like 50-50. Is 1/3 easier to look at that 1 over root 3? Yeah, but just be aware of the ability to split your exponent, right? Think of your exponent properties. How can I rewrite this in an easier way to graph it? I don't really know what to do with that 1/2 graphically, but I do know that that is left 4.
I thought that was a 5, not a 3.
Oh. 3. There you go. Okay. Is this right? Yeah, it is. It's 100% correct. Is this also correct? Yes. That's where your exponent properties are going to come in. I'm not going to test them explicitly, but they're going to show up in problems that you're going to need to use them. Okay? That's an exponent property. I didn't give you property questions only on your quiz. You just had to use them, especially on some of the solving, okay, and how you rewrite the questions. This one is also just log base e. Those are both correct, but just don't forget that log of natural base is automatically e. Okay,